In this video today, we're going to be looking at continuing on with parabolas. This is to do with exercise 7F, applications of parabolas. I do have some key questions there I'd recommend doing in exercise 7F. And these videos are to help you sort of understand how you can apply parabolas and how you can use your existing skills of factorizing, finding the turning point, and apply those to situations that are applied. So that means like projectile moving and finding out the highest point that projectile meets and everything. So these are pretty good fun. Once you get all those core skills together, you can start applying it for real world problems. And this sort of lends itself to a bit of engineering, sort of maths and physics as well, which is great. So let's have a look at this first question here. Now you will need a Classpad for this. We're going to be focusing on the Classpad a fair bit in these first two examples, so just make sure you have that ready to go. So we've got a ball, right? And this ball's thrown upwards from ground level and reaches a height of h meters after t seconds. Okay, now the formula here is h is equal to 20t take 5t squared. Now it's saying sketch a graph for this rule. Now what we're going to do is we're actually going to sketch this in our Classpad. Okay, now they're asking, can you find the T-Intercepts, which is X-Intercepts, and the coordinates of the turning point. We're also going to find some other key features as well. Now, from my experience, using Classpad typically is a weakness in some boys, so just make sure that you're on top of this kind of stuff, because using the Classpad isn't so straightforward at the start. And without further ado, let's go into it. Okay, first thing, I'm going to go into graph mode, and if you do have some stuff, just go clear all. The next thing is we're going to plug in our formula. Now, we don't really have t, so we're just going to use x instead. So 20x take 5x squared. Okay, now one thing you could probably do at the very start is, do you see how that blue box, you can select different things? I've got it around my graph at the moment. You can go zoom, quick, standard. Now, quick standard makes it a -10 by 10 by -10 by 10 sort of view window, and it's just a nice way of getting started. No doubt your view window will be everywhere from the last graph you put in. Now that we've got that, we're going to press this button to graph. We can see that this function doesn't really fit very well into our view. So what we can do is we can click and drag if you so wish. Still not great. So what we can do as well is go zoom, and then we can go use the auto function. Now, if you don't like that, zoom, quick, standard, you can go and press this button here, which tries to find those peaks. Okay, and you can see both of these aren't fantastic. Now, I'm going to show you one that I like. I usually muck around a fair bit, but I love the box zoom just here. And what you do is you click on it, then you drag a box of what you want to see. And you can keep doing this until you've got like a really nice feature of your graph. Now, we're interested, this is remember a ball being moved. We can see here, this is going to simulate that ball. Okay, so first step, getting your view window correct is probably one of the most tricky bits. After that, finding all the key points isn't so bad. So next thing, we want to find some key points. Now that's all under analysis. Then we go G-solve. Okay, now G-solve is a thing that helps find key features in graphs. You can see here, we might want to find a y-intercept. There it is, 0, 0. So we can note that. Analysis, G-solve, we can find our maximum point. There it is. And look how quick that was, 220. We could also find our roots. Remember, root is another word for X-intercept. So we've got this one here, 0, 0, and 4, 0 as well. And with all this information, we can start sketching this graph. We can also do some tricky stuff. We can put in a y-calc. So this is just, I want to find a value, like say for instance, after 1 second, how far has the ball gone? And so that's if you want to find a y-calc, you plug an x value in, 115. Yep, so that's pretty useful. You can also plot another function. I want to find all the points on this graph when the ball is above 10 meters above the ground. Now this is another great strategy by plotting another line, and then we go analysis, G-solve, and we can find the intersection. So here we can see after the ball is 0.59 seconds in to the flight, it's reached 10 meters, and then press the cross arrow, it takes another 3.41 seconds until it's dropped back. So that period of time there is how long it's above 10 meters. So you can answer some pretty tricky questions using your Classpad. Now with that in mind, make sure you know your Classpad. We're going to have a your turn in a bit. I would probably recommend trying this one, seeing if you can get the same result as what I've just done, but in the your turn as well, you can practice the same thing. So let's go back to our example and let's fill in the blanks. Okay, so it's saying sketch a graph, so typically this is a non-calc question. Now we already know the answer from our Classpad, but let's pretend this is a non-calc as well. So sketch a graph using the T-Intercepts. So h is equal to 20t, take 5t squared. Now h would have to be 0 to find the T-intercepts. Then we can solve by factorizing and taking out a common factor of 5t. Ooh. There we go. Now we're going to solve. So we've got this first chunk here, t would have to be 0, and to make this bracket 0, t would have to be 4. So now we've found our T-intercepts. We've got 0, 0, and 4, 0 as well. Now let's see if we can also find the y-int. Well, we already know that. If we sub in x is 0, we've already found it 0, 0. Now what about that turning point? Well, let's pretend that we don't have that Classpad. We know it's 220, but let's just pretend that we haven't seen that. What was our skill that helped us find the line of symmetry between two X-intercept points? We averaged the intercepts. So 4 plus 0 on 2 is going to be 2. And this is our line of symmetry. That's the point where the vertex is going to appear on. And then we sub in 2 into our original formula. So plug in 2. 20 lots of 2, take 5, 2 squared, 40 minus 20, 20. And this is our turning point at 220. Okay, now we're at a point where we can sketch this graph. Okay, so here we go. Now I might draw this over here and then I'll give you a bit of time to do the your turn after this. So here we go. Okay, and then we've got 0, 0 here, and then over here we can put our 4, 0 at 220, got there, and now we can connect these up with some kind of quadratic function. Just make sure it's nice and smooth, like that. Now let's label our axis. On the x-axis, we have our t's. So instead of x's, they've got t's. And on the y-axis, they've got h's. So let's add that to our axis. And then let's put into the situation. So a ball's being thrown up from the ground. So t is time since ball thrown. And this can be in seconds. And on the y-axis there, or the h-axis, I should say, we've got height of ball above ground, and the units for that is in meters. So there we go. We've sketched the graph, and just to double check, yeah, it's within those constraints 0 to 4. So what's the maximum height that this ball is going to reach? Well, we can see here, this is our max height. So we can say after 2 seconds since being thrown, the ball reaches a max height of 20 meters. Okay, now we've done that one there. It's saying how long does it take for the ball to return to the ground? Well, they're talking about this point here, right? So we can see it lifts off here and then it takes 4 seconds for the ball to reach the ground. Because remember, this line here, h is equal to 0, is the ground. Okay, now we've answered all our questions and we've answered in context. Do you see how we're using quadratic here for an applied situation? What I want you to do now is have a go at question 2, just to the right. It's to do with the javelin, and you may see it's instead in turning point form. What I'd like you to do is put this in your Classpad, practice changing that view window, finding all those key features, and then sketching and answering the questions from here. Okay, so pause the video now, have a crack at that question using your Classpad, and then we'll get back to it and see how you went. All right, we're going to go through this question now, and I'm going to move this question over here. So see if I can select this. Don't know how I'm going to. Come on. There we go. Lovely. All right, so path of a javelin. We've got this formula here, and we're going to chuck that into our Classpad. So what I'm going to do here, edit, clear all, okay. And you see it's reset that there. Clear, and let's put this in here. So negative 1 on 16, and then we go x minus 10 squared, and then it's going to be plus 9. Okay, so there we go. We can see our graph has just gone completely AWOL there. Let's go that one there, drag, zoom out. So yeah, I have to press quite a few things here, and let's do some box zooms as well. Ooh, look at that, that's pretty good. So I'm pretty happy with that there. And now, do you see there's no one button you press, you just keep pressing buttons until it looks good for your application here. So we've got, let's have a look at our key features. We go analysis, G-solve, and let's look at our roots first. We've got -2, 0, and let's press the cross arrow. We've got 22, 0. So there are X-Intercepts, and that's like when the javelin has hit the ground, because remember that Y is going to be 0. Analysis, G-solve, let's look at our maximum. So after 10 seconds, the javelin reaches a height of 9 meters in the air. Analysis, G-solve, Y-intercept, we see after 0 seconds, Y-intercept, then the height of the javelin is 2.75 seconds. So that means initially the javelin's at 2.75 meters. So we can picture someone quite tall with their arm throwing this javelin like that. And then this is the arc. Now you may note that it actually doesn't really make much sense to have the negative t values, so you won't be plotting those because it's an applied situation. All right, so what we're going to do now is sketch this graph. Okay, and just to practice, we're gonna, so I'll put in this one here, and this one here, and just draw a nice curve like that, okay? And you can probably clean these up, that's why I recommend using a pencil for these, like that. On the x-axis, we've got D, and this is H, and this is the javelin distance road, so distance, I guess it's horizontal distance, I assume, yeah, horizontal distance thrown, vertical distance. This is both in meters. So this is actually showing, if you were looking on this, you actually are seeing this arc of this javelin over time. It's pretty cool. Now, next thing, we're going to label what we've done. So this is 0, 2.75. This one here was, I think we had 10, 9. And this one here was 22, 0. Okay, now these are our main key points. Now, what I want to do is I want to confirm these using some algebraic skills. So how do we know that that turning point is here? This is the max. Well, we can see that this is in turning point form. And we can see that this is the x of the turning point and the y of the turning point. Sometimes I use a letter P and Q. So turning point is going to be at 10, 9, and that just confirms the answer there. So we don't need any algebra there. If we want to confirm our x-intercepts, and I can draw these on here if I wanted, at negative 2, 0. I don't draw that in because it doesn't make any sense having negative distance. That's throwing it. It's like dropping out of your hand, right? Like Montgomery Burns throwing. So we're going to confirm those. So we go h is equal to 0, sub in. Rearrange. I believe that's 144 actually. Take the square root, plus or minus. D is equal to 10 plus or minus 12. So D is equal to negative 2 or 22. And so this is us confirming algebraically that indeed the X-intercepts or D-intercepts are negative 2 and 22. Cool. Now let's answer all these questions. I do want to practice the Y-intercept as well. Sub in D is equal to 0. It's just one that people usually go, oh yeah, the Y-intercept's 9, but it's not the case. You're plugging in 0 there, and if you crunch it all out, it actually doesn't turn out to be 9. It's 2.75. So just be wary on that. Okay, so let's answer all our questions here. We've sketched, good. What's the maximum javelin height? So the maximum height of the javelin is 9 meters. And that's at a point 10 meters horizontally. So if you look at the arc of this javelin, if you look 10 meters horizontally into the arc, then you'll see it's 9 meters high, and that's the furthest it gets. Okay, what is the horizontal distance that the javelin throws? So it starts at 0 here and it goes all the way to 22. So we can say it travels 22 meters. Okay, now this is our video here on the applications of parabolas. You can see there's a fair bit of work in here, and there's lots of core skills coming through, but also Classpad skills and interpretation skills and sketching skills. So it's all coming together on this one here. That's why I'd recommend doing as many questions as you can from this exercise, and they're also quite entertaining too. In the next video, we're going to be looking at another example of quadratics, and it's probably a little bit trickier, and it starts leading into something called calculus, which you see a bit next year. Thanks very much. Hopefully this video was of some help. Cheers.